Hello YouTube viewers, welcome to my YouTube channel. I am Sri Tips, and today what we're going to talk about is silver refining. Laid out on this table in front of me here is a group of sterling silver items, candlestick holders and some sterling silver bowls, some sugar and creamer dispensers made out of sterling silver, salt pepper shakers, and back here I've got some sterling silver flatware, and over here I've got a bunch of 90% United States minted silver coins. And what I'm going to do with this material is demonstrate how I refine it into pure silver crystal. Okay, before we get started here, I just wanted to give you a quick overview of the material that I'm going to be using to refine here. This is sterling silver. I don't know if you can see that marking on there. It says sterling silver on the bottom. If a maker of these products is going to go to the trouble of making it out of fine silver, or sterling silver, which is 92.5% silver, what they'll usually do is put a mark on the bottom of their pieces. And normally, if it's not marked sterling silver, it's not going to be sterling silver. So you can see the mark there. I don't know if you can see that or not. Some of them are real faint, but they will be marked on the bottom as sterling silver. Okay, what we have over here is a grouping of solid sterling silver flatware, and the way that I determine if this is actually silver or not, rather than silver plated, is on the back of each piece the maker will put a stamp on there that says sterling. If it doesn't say sterling on the back of this piece of silverware, then it's probably going to be silver plated. It'll say sterling right on it. Anyway, I got a couple of sets of sterling there, and we're going to be using that to refine with. One more component to the refining here is a bunch of scrap jewelry that I've got here in this little container. I've already removed all the springs and non-silver metal and other material, stones and so forth, from this jewelry, and we'll be working with this as well. Scrap 925 sterling silver jewelry. I've got a bunch of silver coins. There's a bunch of silver dollars here, some dimes, got a whole couple bags of quarters, some more silver dollars, more quarters, a whole bunch of tubes of quarters here. Here's a whole bunch of sacks of 90% silver dimes. Back here I bought some items at a garage sale here recently. It's silver coins, silver dimes here. And they had them sitting in the back shelf there with a price tag for 20 bucks. So I bought every one of them that they had. So what we're going to do is we're going to take and begin by mechanically cleaning these pieces of silver. And what I mean by that is I'm going to remove all non-metallic material from all this, so that all I have is sterling silver. The coins, I'm not going to refine those. I'm going to keep those just like they are, and I would recommend to anybody thinking about doing this to leave the silver coins like they are. They're a known quantity of silver minted by the United States government, and they will be tend to have a little bit of a premium value to them. So I wouldn't mess with those. You can use the silver coins and convert the silver coins into the pure silver crystal here, but I would recommend you don't do that. And this pure silver crystal is what our final product will be when I get done refining the silver. And as you can see, it's real high purity silver, Probably close to about 5/9's fine. Some of this has been run back through the silver cell 2 times, so it's been double refined. And this is some very high purity silver. This is a silver that I use to make my pure silver bars. And we're going to show you how to do that. We're going to convert all this silver material right here into pure silver crystal. I'm going to show you how to do that right now. Okay, what I'm going to do now is I'm going to go ahead and clean this silver up. I'm going to make sure and wear a pair of gloves here. You don't even want to think about doing this without gloves because this metal is razor sharp and it will slice your fingers apart. What I'm going to do is take all the weighted material out, put it in the trash, and then put the pieces of silver right down here in this little bucket. Alrighty, I've got all the weighted material taken out of the sterling pieces. I've got my flatware here, my jewelry items here. These are pieces of bowls that I've taken the weighted material out. The only thing I really have left to do here is these knives, and I just want to show you one of these right quick. The knife has a stainless steel blade, and it's got a sterling handle with some cement inside of it. So what I have to do is break that, get it started here, and just kind of slowly peel the metal back away down the length of the blade there. It's a pain in the butt to do. It takes a long time to do it. And so I just wanted to demonstrate that these knives are not all sterling silver. This part here, there's some weighted, this is stainless, and there's some weighted material, some cement in here. But this coating is going to be sterling silver. And I found that these knives are about 8 or 10 grams of sterling each. Alright, I've got all the sterling silver flatware here. Here's all the jewelry items that have been cleaned up mechanically. Here's all the silver dishes and candle holders and salt and pepper shakers and so forth. Here's some more of that material here. And here, if you recall from some of my gold refining videos, this is going to be dilute nitric acid that was used to dissolve out silver out of the gold that I had imported, and I saved it in these jars. Well, these jars are full of silver solution, and there's still nitric acid in here that can dissolve silver. So I'm going to use this up by pouring these silver jars into these large 4-liter beakers here, and I'm going to use this solution first to go ahead and dissolve the first bits of my silver here. Okay, I've got the dilute nitric acid solution that already has a bunch of silver and other metals in it in my beaker here. I'm going to go ahead and turn my fan on. And then I'm going to take a torch and I'm going to start burning all this metal, heating it to redness, and burning all the flammable material off of it. And then I'll add it to the beaker. Burning the metal like this burns off any oils, greases, wax, or other combustible material. And if I didn't do this, and if I just threw it straight in the acid, those materials could cause a greasy film to form inside my solution, something I want to try to avoid here. Now I'll do the same with this side. Again, this is silver that was dissolved from incorporated gold solutions. It still has active nitric in it that can dissolve silver. So I'm going to use it first to use up all the residual nitric that's in this solution that I'm pouring in this beaker. Now I'll start adding silver to this beaker. Okay, both of these are pretty full now. Go ahead and put the lid on, cut some heat on them, and we'll go ahead and let these react. The reaction has been taking place now for about 30 minutes or so. What I'm going to do is go ahead and there's some room in there now because the silver is dissolved. I'm going to go ahead and add some more silver. Okay, we've got both beakers back full of silver again. Still got quite a bit of stuff left here that has to be incinerated and then added to the two beakers. So we'll just keep doing this until all that nitric acid runs low, and then we'll go from there. Both of the beakers have been on the heat now for about a little over an hour. If you notice, this one here has slowed way down in the reaction. Hardly any fumes in there. This one's still going pretty good, but it's slowed down significantly as well. So what I'm going to do, I've got some water here, distilled water, just a little over 200 ml. And I'm going to add some nitric acid to that slowly and make a 50-50 solution of dilute nitric acid here. Now what I'm going to do is check the temperature on this. It's going to be hot, so I got to be careful adding that dilute nitric in there. And it looks like we've got 186 degrees Fahrenheit, 85.6 degrees Celsius. So now what I'm going to do is I'm going to go ahead and pour a little bit more nitric acid in this, see if I can get this reaction invigorated a little bit. I'm going to add it real slow here because it's going to want to take off right quick because it's hot. Alright, I'm just going to go ahead and add just a few ml there just to get this thing going. We'll add it slowly, a little bit at a time, until we get all that silver dissolved. Both beakers have been on here a little over 2 hours now. The reaction is stalled in both of them, which means that all the nitric, or most of it anyway, has been used up out of my silver solutions that I began with. So what I'm going to do is I'm going to go ahead and add some 50-50 dilute nitric acid here to each one and get things going again. I'm going to add it slow. First, before I do that, let me get the temperature here. Alright, that's 84.6 degrees centigrade, 184 Fahrenheit. That's 190 Fahrenheit, 87.8 centigrade. Now I'm going to go ahead and add some nitric acid here. I'm going to do this real slow because it's going to be hot. It'll take off on me if I put it in there too fast. Let these continue to dissolve here. This one looks like it's getting ready to run away on me. So I'm going to go ahead and take the lid off, bring it out off the heat, and let it overspill into this container here if it takes off on me, which it did not, thankfully. Now this one's starting to run away on me. What I'm going to do is just take the lid off, take it off the heat for a minute, let it calm down. What happens here is when I added that 50-50 dilute nitric, it goes in and it kind of, due to the difference in density between the 50-50 dilute nitric and the solution that's already in the beaker, the dilute nitric will tend to hang around on the top of the solution here and just kind of float on top of it. And then as it begins to react, the bubbling action starts to stir it up, and then it gets down here and starts stirring from underneath, and it gets the whole solution going. And then it comes in contact with that hot metal, and then the reaction gets real vigorous like that.
So I think we can control it just by taking it off the heat there, letting it simmer down here for a few minutes, then we'll put it back on the heat. Now that things have calmed down a little bit, go ahead and add a little bit more silver to each one.
When digesting silver like this, the goal is to get the silver dissolved as quickly and safely as possible. It requires a little bit of a balancing act between getting the right amount of silver and the right amount of acid, the right amount of heat, all to come together in a safe way to get this silver dissolved as quickly as possible.
Both of the beakers have been on here reacting now for right at 7 hours, and I've got all of the sterling silver from the bowls and the candle holders into the beakers now. So what I'm going to do is go ahead and turn this heat down on low and just let it sit for a while and use up all the available nitric acid that I can, and then we'll go ahead and cool this off and filter it out. The silver has been on now. I left it on overnight on low heat, and so now what I'm going to do is I'm going to go ahead and turn this off and let these solutions cool down. Alright, we got 74.4 Celsius, 166 Fahrenheit. On this one we got 131 Fahrenheit, 55.2 Celsius. And I left those things on overnight, went to bed, And I came out this morning. It's been about 8 hours since I knocked off, so these things have been sitting there for about 8 hours. I'm gonna go ahead and turn the heat off now and let these cool down so we can do a filtration on it. It's important to point out here that there's a bunch of undissolved silver left in the bottom of these beakers. I've even got one spoon over here. I put him in last night before I went in and went to bed. This one's got a spoon in it, and it's got some leftover silver down here. This is important to have because we want some leftover silver in the bottom of the beaker to ensure that we've used up all the free nitric acid. When I go to the next operation, which is cementing this silver out with copper, I do not want a bunch of free nitric acid in there because it will needlessly consume the copper and it will dissolve the silver just as fast as it cements out onto the copper. So I want to consume all the free nitric acid out of these containers before I do this filtration. And I'll go to the next step. I've taken both of the jars of silver down off of the heat. They're down here cooling now. I want to say it one more time. This is so important. Notice that there's undissolved pieces of silver in each one of these containers. That is important because we want to see undissolved pieces in each container to make sure that all the free nitric acid has been consumed before we go to the next step. Okay, I'm just going to do a little review here. I got all the pieces of sterling silver that I had in this bucket. It's all inside these containers, and most of it has been dissolved. I haven't even touched the jewelry yet, and I put a couple of spoons in here to consume excess nitrate. But other than that, all the silver flatware still has to go in. So that's where we are right now. Both solutions have been allowed to cool down to ambient temperature, which today is about 90 degrees Fahrenheit. All right, that one's 34 centigrade, 93 Fahrenheit. This one says 89 Fahrenheit, 31.8 centigrade. All right, here I have a tube. I'm going to fill this up with distilled water. Got to use distilled water here because we're working with silver nitrate in solution. Can't use tap water. I've started my vacuum pump. Now what I'm going to do is I'm going to stick this tube inside the beaker and siphon the solution down here into a flask through a filter. Put the end of my thumb over the tube. Stick the other end up here in my solution, let my finger off the tube, and then siphon the silver nitrate solution down here into the funnel. It's better than pouring it. If I was to pour it, some of the contents has settled in the bottom of this beaker. Pouring it over into the funnel, into the filter there, would cause some sediment to come over and would quickly load up that filter paper. So siphoning out like this is much better. Okay, I've maxed out this flask, so what I'm going to do is I'm going to go ahead and pull this flask that's full of silver off. Put the funnel right in here. Move this one out of the way. It's full of, it's 4-liter beaker, or 4-liter flask, full full of dissolved silver. And well, I've got a couple liters left up here on the table. Set this flask up and just continue the filtering operation. I've got about 2 liters of solution up here left to filter. I got my tube full of water. Got my filter flask down here. I'm going to go ahead and siphon it on in and continue that filtering operation until I get all the silver solution filtered into these flasks. Just wanted to take a look at this filter here. It's got some sediment in it from that filtering operation. And I've rinsed it out real good with some distilled water. That sediment could contain gold and possibly some platinum group metals. So I'm going to save this filter and put it in with my filter storage. Silver is a carrier of platinum group metals and gold. So there's a good chance that there might be a little bit traces of that kind of metal in this residue in this filter here. So I want to save that. Nitric acid dissolves both silver and palladium all by itself. Here's our solution, nice and crystal clear. Here's our other one in a 4-liter jar or flask there, nice and clear, ready to go to the next step of the process here. I've got both of these solutions here filtered, nice and clear, ready for the next step. For right now, I'm going to just set those over here out of the way. And then I'm going to turn my attention back to the flatware there. I've got some distilled water here. It's got a little bit of a copper in it from some previous rinses. I save, when I rinse out my cement silver, I save that distilled water so I can reuse it. But what I'm going to do is add this distilled water. It's got a little bit of copper in it, but you could use just regular distilled water. I'm going to put about a liter, fill these beakers up with about a liter of this water, maybe 1,200 ml or so. And then what we're going to do is start adding some of this flatware to these beakers so we can start dissolving the flatware. Now I'm going to start burning these pieces of flatware down here. These aren't going to be as bad as the sterling silver items. You shouldn't have to heat them to redness. Just heat them up a little bit to burn off any kind of oils or junk that might be on there, and then add it to the beaker. All the silver flatware has been incinerated. I'm going to go ahead and set these now back on the burners here. And then what we're going to do next is add a little bit of heat here. And I'm going to go ahead and pour some nitric acid into each one. Probably about 100 ml in each one just to start off with. This should be at room temperature, which is not that hot right now, so we'll get away with doing this right now. But once this heats up, it'll be a different story. I have to really carefully add this stuff once it gets real hot. But for right now, I'm going to add about 100 ml to each beaker just to kick things off. Okay, we're just going to continue to add small doses of, I've got some dilute nitric acid here. Keep adding small doses of this until we get all this to dissolve, just like we did before with the other material. This is what I'll be using to cement the silver out of the silver nitrate solutions. This is Romax copper wire. I got all, here's some tubing here. I got all this stuff at yard sales. This bundle here was free. The woman said she's tired of it sitting in her garage and told me I could take it for free. That's probably about 10, 12 pounds of copper there. These were all a couple bucks a piece. People buy stuff to buy this wire to do a project, and then they only use a small bit of it, and then it just sits in their garage. And I buy it. I think I bought this one for $5 at a yard sale, and my wife got these two for a couple dollars a piece, and she bought this for $3 out at the flea market. So this is what's available to me. So this is what I'll use to cement out the silver from the silver nitrate solutions. Okay, here I've got some copper wire. This is some outdoor wiring. It's pretty thick gauge. What I'm going to do is show you a way that I found to get the skin off, or to strip it, get the coating off of it. Just take a razor blade here. I got a little screw with a piece of plastic underneath of it, and I just kind of use it as a guide. And I hold the razor blade here. There's probably a better way to do this, but this works for me. And I just kind of pull the wire along that screw in the chair there until I get it all the way down. I've got this is a 6-foot piece of wire here, and this works okay. I mean, there's, like I said, there's probably somebody out there that has a way better way to do this, but this works for me. And then I just peel it off all the way down. And there's our copper wire all stripped off. Alright, each individual strand also has a coating on it, so I just take the razor blade and I find the perfect angle to hold it at, and then I just pull it through and strip the coating off. I'm using copper wire here because that's what I have, and it's probably not the best choice. Copper bus bar is probably better, and the reason this is not a good choice is because when it cements down, what it'll do is it'll leave little tiny pieces of wire in your silver. See how that comes right off? Alright, I'm going to do one more here. Just kind of hold the blade at an angle and get it started. And it just kind of peels that coating right off as you pull it through. Pretty handy. Works okay. And when you get to the end, just pull the coating off like so, all the way down the piece of wire. I guess this isn't necessary. You could just wind that copper up, but what I did is I've got a little meat grinder here that I bought at the thrift store for $3, and I fastened a piece of wooden rod on the end of it with some screws. What I do to make this coil, I got a little hole right there. This coil of the wire, put it down in the hole like so. And flip the switch and hang on. Now what I get is a little coil of wire here. Do the next one. Insert it in that little hole. A little bend, flick it on and hang on. Okay, while I'm waiting for the flatware to dissolve, what I'm going to do is go ahead and start the cementing of the silver here. I'm going to add about 1 liter of distilled water to each of these beakers here. Okay, here's the copper coils. I'm just going to go ahead and lower them down into the distilled water like so. Put little hooks on them so they can hang on the edge of the beaker. Now I'm going to add some of the silver solution and start the reaction here to cement the silver out of this solution using this copper wire. Just going to add it slowly. It should start immediately. You should start seeing some silver forming on those pieces of copper. Okay, what's happening here is the silver that's in solution is coming out of solution on the pieces of copper wire. That's pure silver powder there forming on the copper, and that, as it gets heavy, it just kind of drops off of there. While this silver is coming out of solution onto the copper is dissolving and going into solution here. The two metals are trading places. The copper's going into solution, and the silver is coming out of solution. That's pure silver metal coming out of there. Going ahead and pouring the other solution in the other beaker here. Get that started. Okay, if you take a look at this silver here, it's cementing out nicely onto the copper. I don't have any fumes forming or a bunch of silver floating to the top, which is something you want to try to avoid. If we had excess nitric acid in here, what would happen was the copper would be dissolving, the solutions would be heating up, and we'd have a bunch of fumes coming off of this. But we don't see that in here, and that's a good thing. That's what we want when we do the cementation process here. What I'll do is I'll just go ahead and leave this metal to cement out, and I'm gonna call it a night and go in and go to bed, get some rest. And when we come out in the morning, we should have some nice cement silver in these beakers. Today is day 3 of our silver refining video. Here's our cement silver. This has been allowed to settle all night. here I've got the flatware still dissolving. What I'm going to do is I'm going to start this off by I've got about 300 ml of distilled water in our beaker here. I'm going to add some nitric acid to make a 50-50 solution here of dilute nitric acid. And then what I'm going to do is I'm going to go ahead and add some of that to the silver flatware up here. I'll get this started back up. Everything's at room temperature, so I can add this acid in a little bit more volume of acid here than I normally would if it was hot. And this will just start the reaction. I'm going to turn the heat on low down here, and we'll let that react. Now I'm going to turn my attention to the cement silver here. It's been allowed to react overnight. Go ahead and stir this up. The silver down here in the bottom of the beaker will tend to trap some of the silver nitrate solution, so I want to stir that up real good. Make sure and get any silver nitrate solution that's trapped down inside the cement silver down at the bottom there. Release that so that the copper, it can come in contact with that copper and get all the rest of the silver cemented out. I'll just let these go ahead and continue to react. It's been several hours since I stirred these up. The pieces of copper wire are very thin now, and so what I'm going to do is, rather than try to reuse these, still got a little bit to them, but I'm going to go ahead and stick them down here in this bucket. This bucket here is full of copper. I put all my copper refining waste down here. And so what we're going to do is pull the copper out now of each of these. See, this one here is kind of just went to pieces. That's the problem with using wire. It has a tendency to do this, go to pieces on you. The best material I think to use for cementing silver here is some copper bus bar. And what I'm going to do is I'm going to go ahead and put this residual copper, it's real small pieces, if you can see that real fine piece of wire there. I'll put this in my, this is more or less like my stock pot for silver. I'll keep that piece, that'll still work. Alright, I got all the copper wire out of this one. Got all the copper wire out of this one. There's still a piece of copper pipe in here. I'm going to reuse that. So I'll just leave that in there. All the silver has been cemented out of these solutions now. So all I've got is a bunch of copper. But what I'm going to do is put them down here in this bucket. I'm just going to pour this off. Bucket's full of copper. If there's any other precious metals in this solution, they'll cement out on that copper there. And then once all the precious metals are out of the solution, This blue liquid, which is copper nitrate, will get added to my my waste bucket and for waste processing. A little bit of silver might go over with this, but that's quite all right because I'll be recovering the silver out of this and then the other precious metals that cement out on that copper later on down the line. All my silver waste goes into this bucket. It's full of copper. Here's a perfect example of what I was talking about. A little piece of copper wire here. And what happens is that copper gets consumed during the cementation process and leaves little bits of copper like that in here. That's why wire is not a good choice here. Alright, I'm going to add a few more pieces of silver to each one of these beakers. More coils of silver that I copper wire that I coiled up. I'm using copper here because that's what I have. It's a readily available source of copper and can be used for cementation of silver. It's just not as convenient as like a solid piece of bus bar. Or if you notice in here, I've got some piece of copper pipe that I cut open and stuck in there. I'm going to put some more copper in here. And then I'm going to add some distilled water to each one, about a liter of distilled water to each one. What happens is you don't want to put the fully concentrated nitric or fully concentrated silver nitrate in here. It'll passivate the copper, form a hard crust on the copper, and then the cementation process will stop. So you want to add some distilled water. This process takes a lot of distilled water. Here's our silver nitrate concentrate solution. I'm just going to go ahead and pour that in now. And we'll just let this set and let that silver come out of solution on that copper. Give it a quick stir here, mix everything up. Okay, we're at the conclusion of day 3 here of the silver refining video. Just going to check these things out and see where we're at. Here's all our silver at the bottom of the beaker here. It's been cementing out now for about 2 or 3 hours. Alright. Here's our other jar of silver. I'm going to leave these set until tomorrow. If you look down in here, here's our copper wire. It's still pretty good shape. I'm just going to leave these set in here overnight. Here's the copper wire in the other beaker there. Just leave these set overnight. Now we'll take a look at these jars up here. If you notice, these have been on about 8 hours now. And this one here, almost all the pieces of silver are completely dissolved down there. Just a little bit of few little remnants of silver left down in there. But this one over here has got quite a few pieces left. So what I'm going to do is I'm going to transfer some of the pieces of silver from this jar over into this one. I want a little bit of silver left over when this reaction is complete to make sure I've used up all the nitric acid that's available in here. Just going to take a couple of pieces, see how that's all corroded away and ate up the acid. And I just want to make sure I got some silver in this jar over here that will use up any nitrate so that the jars are even. That should do it. Just let these set now. I'm going to turn everything off. It's the end of day 3.
Well, this will conclude part 1 of the silver refining video. As you can see, there's many more steps in silver refining than there is in gold refining. I've got it to the point where I've got the silver cemented out there, and now what we'll do is we'll pick right up where we left off when I start part 2. Coming out very soon. It should be out in the next couple days, but I try to make these videos as detailed as I possibly can. Remembering when I first started refining about 8 years ago now, how nice it would have been to have some videos like these ones that I'm putting out to refer to when I went to try to do some of these processes. As a result, the video right now is already about an hour long, so I'm going to go ahead and publish this video in multiple parts. This will conclude part 1. We'll pick right up with part 2. Hello, welcome back to my YouTube channel. I'm Sri Tips, and today we're going to be working on part 2 of the silver refining video. But before I get started on that, I'd like to address a couple of questions that were posted in some of the comments from part 1. The most prevalent question is, why didn't I melt the copper wire into a bar and use that to cement the silver out of the silver nitrate solutions? And the answer to that question is, it's not necessary. What it ends up doing is adding more time and expense to an already lengthy process. To prevent the little bits of copper from contaminating my cement silver, all I have to do is keep an eye on this coil of copper when it's in the silver nitrate solution, and when it starts to get real thin, I just pull it out, put it into my silver refining stock pot, and then add a fresh coil of copper wire. Another question that kept popping up is, what do I do with the waste that's produced from refining this silver? The waste is considerable. This is a large lot of silver for me at my level, and there's lots of waste that will be produced. What I'm going to do here is show a little bit of the waste treatment cycle that I use to treat this toxic waste and make it safe for disposal. That will be included in this video. Okay, without any further delay, we'll start part 2 of the silver refining video.
Okay, we're going to begin part 2 right here. First off, everything's been sitting here for 2 days. It's my flatware that's been dissolved. This is the cement silver that's been cemented out with some copper wire. This is my waste treatment bucket for the silver refining waste. This is my waste bucket for the next step in the process to treat my waste. It's full. So what I need to do here is I need to move this, get it filtered, get it in these beakers so that I can cement it out. I need to get this solution out of here into this bucket so that any precious metals that remains in the solution can cement out on the copper that I have in there. I need to get this solution that's been sitting here for 2 days, has everything cemented out of it on the copper, into my waste bucket, right? But I need to first empty my waste bucket into a empty bucket here so that I can treat the waste for disposal. And so what I'm going to do is I'm going to set up and I'm going to do that all right now. Okay, first I'll move these things out of the way. Next thing I need to do is take the bubbler out of the waste bucket here. I just set it down in a container. I'm going to move the waste bucket up here so I can siphon the waste out of the waste bucket into this treatment bucket. Here's what's in the waste bucket. It's a piece of iron. I put all my, every bit of waste goes in here. And then any metals in solution will cement out on that piece of angle iron that's in there. It's all been cemented out now, so what I'm going to do is I'm going to siphon the solution out of this bucket here down into this waste treatment bucket down below. Let it all drain into this bucket so I can treat that with sodium hydroxide. Every bit of the waste that I produce from my gold and silver refining operations gets added to this blue bucket with the piece of angle iron in it. The metals that are in solution cement out onto the iron and fall to the bottom of the bucket as harmless metallic particles. And I just throw them away. What's in solution there, that green solution, will just be iron. If you look carefully at that piece of angle iron, you'll see some copper crystals have cemented out onto that piece of iron. Okay, this waste will get transferred outdoors. I've got an area out here where I treat this waste. I don't do it in my shop because of the fumes it produces. So I got me a little spot here out in the back where I'll set this up to treat the waste. Okay, treating this waste is pretty easy. All I really do is add some sodium hydroxide or lye, and this solution is going to be mostly iron. So I got a long glass rod here that I used to stir with, and I just pour the lye in like this. And then stir it up. What'll happen is the metals will precipitate out as their hydroxides. I do this to a pH of 9. I adjust this pH to 9 to make sure all the metals drop out. At higher pH, some other metals will go back into solution. So I want the pH at 9 for this operation. You've seen how it's turned color there. This is a bucket of waste that has been treated with sodium hydroxide. All the metals have been precipitated out as their hydroxides. And now what I do is I just scoop it out and I pour it into some filters here and filter it out to get all the hydroxide material out of the solution. Just pour it in a coffee filter here. What I'll do is let this material just drain through the filters there, and I'll let it dry out until it's like a moist cake, and then it can be safely disposed of. Under here, if you look, you'll see that there's some liquid in there. That's going to be a caustic liquid, and what I do with that is I add some pH decreaser to neutralize it to a pH of 7. And then that can just be poured down the drain safely. Now what I want to do is get this blue liquid, which is my silver refining waste, into my waste treatment bucket here that has pieces of angle iron in it. So what I'm going to do is I'm going to set this down. And put the blue solution up here on the fume hood so I can siphon it. Okay, I've got a tube here full of water. That's my copper nitrate solution. It's waste. Had all the precious metals cemented out of it. I'm going to transfer it down here into my waste bucket. But before I do, I'm going to put another piece of angle iron in here. This angle iron, what it'll do is it'll cement out the copper onto those pieces of iron. Okay, I've got the copper solution down here in my waste bucket. It's got some piece of angle iron in it. You can see the copper starting to cement out on the iron already. That pink colored metal right there is copper cementing out on the iron. That's what I want to see. What I'm going to do is I've got a bubbler here. Keep the solution moving. Got air moving through it. I just put it down into the bucket. There's a hole in the top here. I put it through there. And stick it down in the bucket so I can get some stirring action out of that air bubbling through the solution. And I just keep it right down here below my fume hood. Okay, now I've got some room in my silver refining waste bucket there. It's got some solids down on the bottom of it. Looks like some copper chloride or something in there. I don't know what it is, but anyway, I'll recover the precious metals out of here. It's full of copper wire. I'm going to set that down here below my fume hood. And what I'll do now is bring back the two solutions that I've cemented the silver out with copper wire. And what I'm going to do now is siphon this into this bucket. Alright, now I've got a tube full of water, same drill. Go ahead and siphon the waste copper solutions out of these two jars into my silver waste bucket here. Okay, now what we'll do is take the copper out of here, out of these cementation buckets. I'm just going to stick it here for right now as a temporary hold. And as you can see, silver refining is much more detailed than gold refining. Set those off to the side. Now what I'll do is I'll go ahead and collect the cement silver in some funnels. Okay, whenever I'm doing this, I use a double filter paper in the funnel. And the reason for that is when I stir this metal, if I just got a single filter paper in there, it could tear the filter paper, cause it to fail, and I'd have to start all over again. I've found that by doubling up the filter in here, I can avoid having problems with the filter paper failing. Okay, now I'm going to go ahead and get the silver in the filter funnel there. What I've got here is some boiling distilled water. I'm going to carefully rinse the silver out now, try to get all the blue solution out that I can with this boiling distilled water. Switch flasks now. This could go in the waste bucket over here that has the copper in it. Just pour that right in here now. So I'm just going to try to get this funnel off against the vacuum. Put it in this fresh flask. This can be poured in the bucket here. As waste, then we'll cement out any precious metals on the copper in there. And then I'm going to rinse this silver one more time with some more boiling distilled water. One more time. Notice the pale blue color of the solution draining down into the flask. That's an indication that all the copper has been rinsed out of this cement silver. I've turned the vacuum off. I'm going to go ahead and put the silver up here out of the way. And what I'm going to do now is, this is distilled water with a little bit of copper in it, and it's still good, can be used for cementing silver out later on. So I'm going to go ahead and pour it in this container right here and save it. Distilled water with a little bit of copper in it. It's still usable, so I'm going to save it. Okay, one more rinse. This is hot tap water this time, not distilled water, it's tap water. We'll give it one more good rinse here, and then we'll put this cement silver in a container and dry it out. Notice that the solution going into the flask is nearly colorless. I need to take the silver now and put it in a dish and dry it off. So I need to gain some room here. I got to move all this stuff out of the way before I proceed. I want to do that on camera, so what I'm doing makes sense. Get these out of the way. I'm just going to get it out of here. Now what we're going to do is, I've got a dish here, casserole dish. I'm just going to take the funnel here. You got to remember, this is a plastic funnel. I'm just going to slam it into the dish here to get the silver out. Just like that. Comes out in a nice cake. It's all out of the funnel there. Put it right on the heat here. Turn it on some low heat. And we'll let that go ahead and dry out the silver powder. Okay, while our silver powder is back here drying, we'll go ahead and set the filter flask up here for another filtering to get some more of the silver powder out of that copper solution. I use 2 filters here. The reason I do that is because when the filters get wet, they get real weak. They don't have much strength to them at all, so I put two filters together in here to form a double filter to try to keep the filter strengthened so that when I stir it with a stirring rod, it won't break the filter. Now what I'll do is transfer the rest of this silver from the first beaker into the funnel. And that'll free up this beaker so I can use it for cementing out the other silver from the flatware. We'll go ahead and start putting this silver in there now as well. A piece of copper in there. There's some copper wires in there. I'll try to get them out. They'll break the filter paper. Boiling distilled water. I'm going to go ahead and rinse the silver powder with some boiling distilled water now. Okay, I'm going to go ahead and transfer the flask now. Dump this in my waste bucket. Another rinse with boiling distilled water here. As before, what I'll do here is save this distilled water. It can be reused. Put in this jug here. I'm going to do one more rinse here with boiling tap water. There's a piece of copper wire. Try to get that out of there. I decided to do a second rinse with some more tap water here, hot tap water. There's another piece of copper wire. Should rinse it out pretty good there. Now I'll take the funnel, put the silver in it, put it in this casserole dish here. Just like that. And then we'll stick this over here on some low heat and let that dry out. I'm going to freeze up these two beakers for cementing out more silver from the flatware. I've got my filter flask set up down here. I got a tube of water, and what I'll do is go ahead and siphon this solution now into my filter flask. While my silver solution filters here, I'm going to go ahead and look at my cement silver. I've got a spoon here that's ice cold, and I can tell when this stuff is dry by holding that spoon over the silver. And if I don't see any condensate form on that spoon, like I don't see it, that means that this silver is bone dry. It's been on here a couple hours drying. And they're both bone dry, so I'm going to go ahead and turn the heat off here and get these dishes of silver out of here so we can continue with the process here. I'll take the silver paper out and put that in with my silver paper storage over here. Just got some plastic bags here. I just stick this in. One of these days I'll process all those filters and get the silver out of them. I've got all the silver siphoned out of these beakers now from the flatware. It's filtering down here. I've got some the jewelry items left to dissolve yet. Over here I found I had some more solutions from my gold refining operations that have silver in them. So what I'm going to do is I'm going to use this liquid, add it to these beakers to dissolve the rest of the flatware and to dissolve the jewelry items. I've got this silver solution here from my gold refining operations. It's full of silver and it still has active nitric acid in it. So I'm going to pour it in these beakers to continue dissolving the silver out of them. I'll set these back on the burners and start adding some heat. Get the rest of the silver dissolved. Now I'm going to incinerate the jewelry items here. I'm just going to move it into this dish over here. It's just a big melt dish, and burn it off a little bit. I'm going to save a little bit in reserve in case I overshoot with the nitric in here, and I need some additional silver to consume some excess nitric acid. Incineration is usually the first step in any refining process. It burns off the oils and greases off the metal and prevents that scum from building up in the reaction beaker there. Now I'm going to put the silver in the jars here so they can dissolve. I'm going to put most of it in this jar because this jar has more flatware left in it. So most of the silver jewelry that I just incinerated is going to go in this jar here. See if I can do this while you can watch me on the camera there. And then I'll just put a few pieces over here to try to even it out. Okay, while I'm waiting for this silver back here to dissolve, I'm going to go ahead and get the silver concentrated solution that I just filtered and start adding it to these beakers to cement out the silver out of that solution. This is distilled water that I saved earlier from the rinses, and what I'll do is add this to the beaker. You want to dilute this concentrated silver nitrate solution before we go to cementing the silver out. If we left the concentrated solution undiluted, then what will happen is, this is more distilled water. What happens is the concentrate will form a passive layer of silver on the pieces of copper wire, and the cementation process will cease. So we want to dilute that with some distilled water before we get started. Here's the copper that I saved from the last cementing operation. I'm going to go ahead and use this in this cementing operation here. What we're going to try to do today is demonstrate how to do this without letting those little pieces of copper form in the beaker. So we're going to add 3 to this one and 3 to this one. And what I'll do is pour some concentrate in now. Now this is a piece of silver pipe that I used in the last operation. Here's our concentrate. Here goes the concentrate into the solution with the copper. That's about 750 ml of concentrate in there with 1500 ml of distilled water. As you'll see in a moment, this will end up being too much of the highly concentrated silver nitrate solution. And the same for that one. Go stir it up here with a stirring rod, get the solution mixed up real good. Okay, what's happened here is I've added too much of the concentrate. It's formed a passive layer over the copper, and the cementing process is not working. In the next segment, what I'll try to do is add some nitric acid to kickstart it. Some free nitric acid is required for this reaction. Here's some nitric acid. I'm going to pour about 1 ml in each beaker here. That should be enough to get this started. Now I'm going to stir it up. Here I'm starting to get a little frustrated, but this will end up being a valuable lesson in silver refining on how not to add too much of that concentrate when cementing the silver on copper. Okay, here's some of the joys of silver refining. I've got the copper wire in there, and for one of 2 reasons. It's not cementing out. See how white that is? It's probably formed a heavy passive layer on the copper coils. So I'm just going to take these out, put them in the waste bucket, and start over. See how white that is? That's a heavy passive layer of silver on there, so that the silver nitrate solution can't contact the copper and cement out. So I'm just going to throw this in my waste bucket and start over. Now I've got some fresh copper coils here. I've got some more distilled water. I'm going to dilute this down a little further to see if we can get this to start cementing out properly. before I go all in and put a bunch more copper in there and have it do the same thing, I'm just going to stick one piece in at a time, just submerge it a little bit and see what happens here, see if we get the same reaction. If I do, then I'll have to adjust something to get the silver to start cementing out properly. Now that's looking much better. I think we're going to be good now. I've got the proper concentration of silver in there and some fresh wire. I think I'll go ahead and add all the wire now, and we'll go ahead and start this process. All right, here we go. Let's see what this is going to do over here. Yeah, it's looking right. That's looking right. It's been about 5 minutes since I added the water and the fresh silver or fresh copper coils there, and everything seems to be moving nicely now. I had to get everything adjusted correctly in order to make this reaction take place properly. It's a good thing we've seen that on the video here. Shows you what can happen if your solution is over concentrated, or if you get a passive layer formed on your copper coils. It's been about 30 minutes since I added that fresh copper, and looks like things are going okay here. Stir it up a little bit, and I'm getting a little bit of heat and a little bit of stuff floating on top. That's probably from the nitric acid that I added earlier to try to jumpstart the cementation process. But that'll consume, that'll get used up in here. I didn't add that much, so we should be okay. But everything looks like it's going okay now. Silver's been cementing now for about an hour and a half, and I'm going to go ahead and stir this up now. We're going to check things out in here. This is looking right. This one's looking good. One of the questions in the comment section from part 1 was, how can I tell when the silver's cemented out? You see that pink colored metal there? That means the silver has come out of solution in that beaker. Over here, if you look at this, you'll see that there's still silver forming on the copper. That's that gray powder on the copper there. That means this solution still has silver in it, and that's how I tell the difference. All right, back here, the last of the silver still dissolving. I've got some 50-50 dilute nitric I'm going to add slowly here. What I'm going to do now is I've got some more concentrate here, and I'm going to go ahead and add a little bit more concentrate to each of these beakers. Not very much, maybe about, I'll say 500 ml or so. Actually, I'm gonna only add about 250 ml there. Stir it up. Now after adding that fresh silver nitrate concentrate, when I pull these pieces of copper up out of here, you're going to see that they're coated with a silver coating, silver powder. That's how I can tell if the solution still has silver in it or not. When I pull the copper out and it's loaded with silver like that, that means that there's still silver cementing out in this solution. It's been about 5 hours since I first started doing this. I'm going to check on these pieces of wire now. They're still in pretty decent shape. They're getting thinner. You can tell they're thinner. I'm going to leave them in there a little longer. And what we'll do is, before these things can get so thin that they start breaking off and leaving pieces of little pieces of copper wire in my silver, I'll take these out and put some fresh coils in, and that'll eliminate the small pieces of copper wire that get in there and contaminate the cement silver. Now this one's significantly smaller. In fact, if you look right there, that guy is so thin he's getting ready to break off. I'm gonna go ahead and pull these out now and put them in the waste bucket and put some new copper coils in this bucket right here. Yeah, he's getting real thin, so I'm not going to let it stay in there any longer. Go ahead and put it in the waste bucket, and we'll put some new copper coils in this one. I just inserted these fresh copper coils here. As you can see, silver's still forming on it, so there's still silver in here that's cementing out on those fresh copper coils. Getting ready to call it a night. In this beaker, the copper coils are nice and fat, so I'm not worried about them being too thin and breaking off overnight. On this side, these are kind of thin. I'm not going to leave that in there all night. I'm going to put this in the waste bucket over here. I keep calling this my waste bucket. It's actually my silver refining stock pot. And I'm going to go ahead and put the small copper coils that's been in the solution here. And I'm going to put some fresh fat ones in there. And that way we can avoid getting little pieces of silver or little pieces of copper in with our cement silver. Stir these up real good. Leave these sit in here overnight. Cement the rest of the silver out. Alright, before I retire, I'm going to go ahead and try to get the rest of this concentrate into these beakers so they can cement out overnight on that fresh copper wire that I just added. See if we can get it all in there. quick stir here, and in the morning should be able to come out, have plenty of cement silver in these two beakers. I don't know if you can tell, but working with this silver is a real, I shouldn't say pain in the butt, but it really is. I mean, it's a lot more steps, a lot more involved in gold refining, a lot more messy, a lot more things to go wrong. But this is what we go through if we want to get some pure silver crystal. It is day number 6, the following morning, and what I've got here is my cement silver. It's been cemented out. I'm going to stir this up real good. And what I'm going to do, I believe here, is go ahead and wrap this part of the video up. This silver is cemented out. What I'll do is I'll drain this off into my silver refining stock pot, get the cement silver out in a funnel, rinse it out real good, put it into a casserole dish and dry it like I did this. Back here, the rest of my flatware has been dissolved. That'll get filtered out and then added to these beakers and cemented out as before. And I'll collect up all the cement silver. And in part 3 of the video, what I'll do is I'll melt this cement silver up into some silver shot, and then we'll construct a small silver cell and show how to turn the silver shot into pure silver crystal. One more thing I just wanted to point out, that I've demonstrated how you can use the copper wire and not contaminate the cement silver with bits of copper wire by taking the wire out as it thins out and adding fresh coils. You can see here it's nice and fat still. Same thing over here. So using the wire is just fine, just like it is. Don't have to melt it into bars. If you just keep an eye on the pieces of wire, when they start to get real thin, take them out and put fresh coils in. Okay, this will conclude part 2 of the silver refining video. I hope I answered some questions in this video about the waste treatment, about how I can tell when the silver cemented out of the solutions on the copper, and also about how to go ahead and use copper wire to cement the silver out of the silver nitrate solutions. You can use it. It's not a problem. Just got to keep an eye on it, and when it gets real thin, take it out and put some fresh coils in. Okay, in part 3 of the video, what I'm going to do is melt the cement silver into shot, and then I'm going to show how to construct a small 1 liter electrolytic silver cell. I'm going to use a power supply from an old scrap PC computer and a 1 liter beaker, and we'll assemble that, operate it, and produce some pure silver crystal with it. And we'll do that in part 3, coming up very soon. Thanks for watching. Hello YouTube viewers, welcome back to my YouTube channel. I'm Tips, and today what we're going to do is we're going to do part 3 of the silver refining video. I'm going to begin by showing how to construct a small 1 liter glass silver cell in a beaker like this right here. It's a 1000 ml thick walled 1 liter beaker, And what we're going to do is construct that for you, show how to make a power supply out of a scrap PC, and then we're going to use it to make some pure silver crystal like we've got in this bowl right here. It's about 5/9 fine pure silver crystal, just as close to pure elemental silver as you can get. What I'll be doing is using the silver that we recovered in the previous 2 videos. I've got a couple of containers here full of cement silver powder from those videos, and we'll take this, melt it into shot, and then run it through our electrolytic silver cell. And without any further delay, I'm going to get right to that and show you exactly how to do that right now. This is a shot of my waste treatment bucket. As you can see, the copper has cemented out onto this piece of iron in here. The solution is no longer blue. It's green, which means all I have in solution here is iron. All the copper's been cemented out, and that's what I want to see in this bucket. Alright, we're going to start the construction of this small 1-liter cell by using a 1-liter beaker here. It's a thick-walled, heavy-duty glass 1-liter beaker. This will be the housing for the cell. And right now what I'm going to do is make a cathode for the cell. This is a piece of graphite, hard graphite. I bought it online on eBay. It's about a 1/2 inch thick, 2.5 inches by 2.5 inches square. What I'm going to do is I'm going to take a drill bit, drill a hole into it. The drill bit is about the same size as this 10 gauge copper wire here. And what I'll do is drill the hole in here, fit the wire down into the hole that I drill, and then I'm going to use a 2-part epoxy to cement the coating of the wire to the piece of graphite block there to hold it in place real good. I'm not going to put any cement on the copper. I want that bare going down in the hole so that it makes good contact with the graphite block. Then, once this epoxy sets up, I'm going to use some silicone clear sealant to form a protective barrier over that 2-part epoxy. Okay, the hole in the block is just a touch larger than the piece of copper coming out of there. So what I'm going to do is I'm just going to deform it just ever so slightly so that when it goes down in there, it'll form an interference fit before I glue it in. Just kind of bend it just a little bit maybe so that when it goes down in there, it presses up against the sides and forms a good tight fit like that. Now what I'll do is mix up a little of this 2-part epoxy. Loctite Quick Set Auto Epoxy. Takes about 5 minutes to set up. And I'm just going to put a drop on the bottom of this soup can here. A drop of each one. If you can see that or not, let me see here. Like so. Got a little bamboo skewer here. I'm going to mix it up real good. This is an old PC that I picked up at the thrift store, 13 bucks. And I chose this one. I've been looking for one like this for a while. You don't have to have this, but I chose this one because it has an on and off switch on the power supply. Okay, when I turn this power supply on, the fan doesn't start there. And what I realized is you got to come around here, press this little button right here on the front, and when you do that, the fan starts. So that's what I wanted to do. I just wanted to make sure that this power supply was at least running, and as you can see, it is. Next, I'll remove the power supply from the PC and plug the electrical current. I'm going to take the panel off over here. There's little screws in the back. Other one down here. And on this particular scrap PC, the cover just comes off the side like this and exposes the internal workings. And now what I'll do is take the screws. There's 4 screws up here that hold the power supply in. Take those 4 screws out. One more. And then we have access to the power supply here. And this is the unit that we need. 2 orange wires and 3 black wires. I'm going to save this connection, and I'm going to cut away all the rest of them from this gaggle of wires right here. So I'm just going to take a pair of cutters, no power to this thing now, and start cutting these other ones away. I'm going to save this one right here. This is going to be my good power supply wire. So all the other ones, I'm just going to cut them away. And there we go. Got the power supply free from the rest of the PC there, with our single output wires that we'll use to wire up and power our electrolytic silver cell. Okay, before I can use the power supply, I had to take out these 4 screws, remove the cover, and there's a wire in here that has to be jumpered. It's the green wire. There's only one green wire here. And what we need to do is connect this with any black wire. So I just pulled out a random black wire and this green wire. And I need to take and bare these. And what I'm going to do is put a wire nut on it and then put the cover back on, and then we'll test out the power supply. I've completed the jumper connection in here. I put the case back on. I plugged it in. I turned the switch on and the fan is running back there. So now what I'm going to do is I'm going to put one of my probes. I've got it set for 20 volts DC. I'm going to stick one of my probes in the black, in one of the black wires there, and stick the other probe in the orange wire. And you can see we got 3.4 volts DC. That's perfect for our silver cell. Okay, now I'm going to trim the plug off of this. I've got the power supply disconnected. Just trim this plug off here. And what I want to do is I want 2 orange wires and 2 black wires. So I want 2 orange and any 2 black. It doesn't make any difference where they come from. Yeah, so I got 2 black, 2 orange. I'm going to trim the rest of this off so it's not in the way. Now what I'm going to do is I'm going to bare the ends of these wires, twist these together, and then I got some copper clips here. I'm going to attach those with some screws. Now our power supply will be done. I've got the power supply finished, ready to be used for our silver cell now. I'm going to test it. Connect the black wire here to the black probe on the meter. The orange wire to the red probe. And I'm going to turn the unit on. Got it plugged in back here. Got the on-off switch, which is nice. You don't have to have the on-off switch. It just makes it nice. You can turn it on and off as you need the power. And there we got 3.4 volts. Ideal for our electrolytic silver cell. Here's our graphite cathode that I've epoxied the wire into. It's set overnight, 24 hours. That epoxy is hard as a rock. It ain't going nowhere. Now what I'm going to do is I'm going to cover that up with a little bit of silicone. Just regular old window caulking for your bathtub or your windows, and just kind of dab it on there and just kind of put a bead around over the top of the epoxy. Just a 2-layer protection. Make sure we don't get any of the electrolyte in there where that copper wire is. I want to keep it isolated from the silver cell electrolyte. And that should do it. Okay, what we'll do next is I've got a little piece of paper towel here. I'm just going to wipe the exterior of the piece of wire off real good, make sure it's clean, because it will be submerged in the electrolyte. And now I'm going to shape it by bending the wire so that it fits down into the beaker, like so. So it lays flat on the bottom. And then I'm going to take the upper part of the wire and bend it back like this. And so we'll have the cathode for our silver cell isolated down in the bottom of the beaker there. I'll bare the end of this wire right here. I'll strip the coating off of the wire right here, and that'll give us a place to attach the negative side of our power supply to. So I get that stripped off there, just like that. Okay, now we're going to move this out of the way. And we're going to work on the anode basket now. The anode basket, I use these Rubbermaid little food storage containers. My wife will be delighted. She's been wanting to throw this away. And what I'm going to do to make the anode basket is we'll begin by cutting away this lid. Got a sharp razor here, and what I'm going to do is just carefully cut along the upper edge here of the lid and remove the inside material from it. Alright, there we go. We got this out of the way, and what will happen is we can use this as a retainer around the outer edge of this basket to hold the anode basket in place. Now that we've got the lid fitted, I'm going to go ahead and take a 1/4-inch drill here and drill some holes in the bottom of the anode basket. Drill some random holes. This is so that the silver electrolyte can pass through when it dissolves. Now we'll take a sharp knife and trim away the excess plastic from that operation. Okay, I've got the anode basket done. I'm going to set this out of the way. What I've got here is a small plastic lid for a small bucket. And I'm just going to cut the center of this out now with my sharp knife. And what we'll do is use this to cover the silver cell with and to hold our anode basket. Alright, this is going to be used as a cover for our silver cell. I've set right on top just like that. What I'm going to do is take the anode basket now, pull the cover off, and I'm going to trace the pattern of the anode basket on our piece of plastic that we cut off from the lid there. Like so. Now I'm going to take a sharp knife and just cut along this line here. Okay, this piece will serve to sit atop the silver cell and hold the anode basket for us, like so. Okay, now I'm going to install the filter bag in the anode basket here. This is a Dacron filter bag for a shop vac. The number on it here is 90115 type E, Echo, Echo. And what I'll do is go ahead and open this up. Okay, the Dacron filter has a little rubber ring on it here. It's got a tag on it. I don't want either of those going down inside the anode basket, so I'll make sure those stay clear. I'm using an old paper towel tube here to shove the anode filter down into the bottom of the basket so that it bottoms out real good, making sure I don't have the tag or any of the rubber down inside the basket. I take the retainer ring, I put it over the tube like that, and then I hold it down with my chin, and then just make sure that the retainer ring seats nicely and holds the basket in place. That basket's going to want to come up out of there as I press this retainer ring down on here. So that's why I hold it down with the paper tube. And there we go. Now I'm going to take a brand new razor blade here, nice and sharp, and trim away the excess filter basket material. Just go around it like this and trim all that excess stuff that's hanging over the edge out of the way. There's our prepared anode basket with a filter, ready to be loaded with some impure silver shot for the silver cell. Our silver cell is constructed, ready to go. All the components are there. I'm going to set that off to the side now. Our power supply is all rigged up, ready to go. Let me cut this wire off here. This is not needed. Let's get rid of that. One last thing I'd like to do before I proceed here is I've got a automotive type fuse holder here, and I bought some 3 amp fuses to go in it. What I'm going to do is I'm going to cut the positive wire here and strip the ends off and put this inline fuse holder in place as a safety precaution. Okay, what this inline fuse will do for me is, if as the silver crystal grows in the silver cell, it will start to grow upward in the cell. If it makes contact with the anode basket and burns through the anode bag, then the amperage will immediately rise and blow this fuse and save my batch of pure silver crystal. I've got the cell constructed now. I'm going to move this out of the way. I've got the power supply ready to go here with my inline fuse. I'm going to set that out of the way. And what we're going to do now is make the electrolyte. I've got a scale here, and I've got a bag of pure silver crystal from a previous refining. And this is 5 troy ounces, or about 156 or so grams. And if you put it on the scale here, I've got it marked. It's 5.07 troy ounces of silver. The bag weighs 0.120 troy ounces. The total will be 5.190 troy ounces. And what I'll do is use this silver for the electrolyte for the silver cell. Okay, to make the electrolyte, what I'm going to do here is, let's get this out of the way. Pour the silver crystal into this tall form beaker. And then we're going to go ahead and top that off, or add about some distilled water here till about the 250, 300 ml level there. That's 250 right there. That should be good, just right there, fine. Okay, I've got the 5 troy ounces of silver In a beaker here, I've added about 300 or 250 ml of distilled water. Now what I'll do is I'll go ahead and put this on the heat. What I want to do here is slowly add nitric acid to this. Remember to use distilled water here. I can't use tap water because it has chlorine in it. The chlorine will mix with the silver nitrate and form silver chloride, which is something I want to avoid. Right now I'm going to add about 50 ml of nitric acid to the silver. I'm going to cover it up here, and we're going to put it up on the heat and let it dissolve. The silver nitrate solution there has been on boiling now for about an hour, and a little bit of the crystal has gone into solution. I'm going to add some more nitric acid now. I'm adding concentrated nitric acid here, about 68 to 70% concentration. Just going to pour it straight into the beaker there. This thing is hot, so I've got to do this real careful. Otherwise, it's going to want to boil over on me. Very slowly. Okay, I added about 30 or 40 ml of concentrated nitric acid there. Like I said, this is real hot, so you got to add that carefully, otherwise it'll boil over. It's been about 30 minutes since that last dose of nitric acid. I'm going to add a little bit more here. Probably about another 20 ml. Very slowly because that solution's real hot. Bit more distilled water so that the silver has a place to go to when it gets dissolved. While I'm waiting for the electrolyte to dissolve, I'm going to go ahead and cast me a cement silver bar here to start making my anode bar for the silver cell. electrolyte has been on the heat there for about 4.5 hours. If you look down in there, you'll see that there's just a few grains of silver left over, no fumes. And so what we're going to do now is turn the power off. And I'm going to take this off the heater there, and we're going to let this cool down. What I've got here is a melt dish that I've used to melt some silver in. And what I'm going to do to begin this process is I've got a small drill bit here. It's 3/32. I'm just going to drill a small hole in the bottom of this melt dish right now. There we go. Got a small 3/32 inch hole drilled in the bottom of this melt dish. Here I've got a container of my cement silver. Over here I've got the melt dish that I just put the hole in it. It's suspended in a steel ring here. Underneath that is a map gas torch that I've got just laying on the sill of my fume hood. The flame directed at the hole. I've got this on a ring stand with a weight here to hold everything in place. What I'm going to do is go ahead and put some of the cement silver into the melt dish, melt it with my oxyacetylene torch, and drip it into this bucket of water I've got down here. It's a 5-gallon bucket of water with a steel container down inside of it. Now I'm going to go ahead and load some of the cement silver into my melt dish here with the hole in the bottom. Now I'll start the torch up and commence the melt. Well, this didn't work out exactly as I'd planned. Here's our silver shot in here. And apparently I didn't have the water deep enough or whatever. It just made a giant clump of silver. It welded together as it went through the water and stuck together. It's still molten. And it welded together. So what I'm going to have to do here is figure something else out to make the shot. I've reconfigured my melt setup here. I've got my melt dish set up with some cement silver in it here. I've got a metal container down here with my circulating pump, circulating the water. Over here I've got my electric melt pot set up, and I'm going to fill a full charge of metal into that, melt that, and what I'll do is when I get this melted, I'll take the metal that's melted in the melt pot and pour it into the dish and get it all to go down here and make shot all at once. I've got my chunk of silver here that welded together from the last attempt, and I'm just going to go ahead and stick this right in with the cement silver there, and we'll melt all this all at once, and hopefully we'll I'm going to put some ice down here. Hopefully we'll be able to make some good shot on this attempt for our silver cell. That worked out pretty good. Here's our silver granules, suitable for running through the silver cell. Worked out pretty good. Pleased with that result. Now I'm going to dump the tap water off here and then get the silver granules on some heat and dry them out. Okay, I think the silver is completely dry now. Yeah, it's all dried out. We'll let this cool down, and then we'll go make preparations to get the silver cell in operation. I'm going to measure the silver now, get a weight on it. Zero out the scale. Just going to try to pour this in here. See what we got. That's 741 grams. And then I got the silver from the first melt. I'm going to add that to it now. So we got 870 grams of cement silver that's been melted into granules for the silver cell. I'm ready to assemble the silver cell now and put the electrolyte in it. First, what I'm going to do is take out the components here, set these off to the side. I'm going to put a filter into the beaker. I've got a pre-folded filter here. It's a 102 filter. And what I want to do is filter the electrolyte into my silver cell. Notice I've got just a little bit of undissolved silver in the bottom of that beaker. That's what I want to see. That means all the available nitric acid's been used up. It's going to pour it right in the filter now and filter it down into the silver cell. This is our electrolyte for the electrolytic silver cell. Okay, while that's filtering, I'm going to go ahead and load up the anode basket. I'm going to put some impure silver into the filter here. Get it ready to submerge into the cell. Now I'm going to stick the anode bar on top of the silver that's in the basket there. I want that anode bar nice and chunky so that as the silver dissolves in the anode basket here, it presses the silver on top down into the bottom that's submerged in the electrolyte. I'm going to go ahead and bury this in impure silver shot to make sure we get a good connection, good electrical contact. All the electrolytes pass down through this filter. Now I'm going to go ahead and rinse it out real good with some distilled water. The filter's been rinsed out now. What I'm going to do is remove the filter to this container over here. Set it off to the side. And what we'll do now is I've got some distilled water here. I'm going to fill it up to just above the 1000 ml level here with distilled water. Need a little bit more there. We'll go about a ½ inch above that 1000 ml level. Then we're going to take a glass rod here and stir this up and make sure everything's nice and mixed real good. Now I'm going to go ahead and put our cathode, our graphite cathode that we made, down into the cell. It's going to displace some of that electrolyte a little further. And we're going to put the cover on. And I see right now that I'm going to be a little too full. I put too much in there. When I put the anode basket down in there, it's going to overflow. So I'm going to have to remove some of the electrolyte. Got it a little too full here. I'm just going to take some of the electrolyte out now. Okay, I've lowered the level of the electrolyte. Now we're going to go ahead and finish assembling the cell. We'll put our cover on here. And then drop in the anode basket carefully. Make sure I don't overflow it. That looks about right there. You can see the levels right up near the rim of the beaker, but that's okay. The more that we have submerged, the greater the current flow will be. And this can be saved so that we can rehydrate the cell later on if some of that electrolyte evaporates down. So we just save this and set it aside to rehydrate our cell. Okay, I've got the cell assembled. I've got our PC power supply. It's plugged in. It's turned off right now. And what I'm going to do is attach the positive end up here to my anode bar in the anode filter basket. And I'm going to attach the negative end of the power supply to the cathode down here in the bottom. Like so. And then we're going to turn the power on, and we should have a working electrolytic silver cell. Here we go. I just energized the power supply. I don't know if you can see that on camera or not, but I'm already starting to get some silver, pure silver crystal forming on the graphite cathode down there. The silver starts to grow on that thing almost instantly. So we're getting silver built up on the cathode right now. As you can see, the silver is starting to grow rapidly on the graphite cathode there. It's been working now. It's been running for about 30 minutes. That's 30 minutes worth of growth. Okay, I came back in from work and the crystal had grown this much. I've got a glass rod here and I'm going to go ahead and push these crystals down. And we'll go ahead and let it run. Well, I finally got the silver cell operating. It's been years since I've operated a small silver cell like this. And if you look, the crystal's already halfway up to the anode basket. And I've only been here about half an hour since I knocked those crystals down. So the crystals have got to be checked at least hourly and knocked down. Otherwise, they'll make contact with the anode basket, burn a hole through it, and contaminate the pure silver crystal. It's been about 45 minutes since the last time I tamped these crystals down. They're growing rapidly, and this has to be done every hour. If we don't do this, what will happen is the crystals will contact that basket, burn a hole through the bag, contaminate the batch of silver. So they got to be knocked down every hour. What I'm going to do now is check the voltage going through the cell. Got my meter over here set to 20 volts DC. Put the black probe on the cathode side over here. The red probe on the anode bar up here. And we see we've only got 2.8 volts going through the cell. Okay, as you can see, I'm getting 3.4 volts out of the power supply. when it's disconnected from the cell. Now I'm going to reconnect it to the cell here and see what the voltage is. I'm only getting 2.8 volts. I'm going to go ahead and feed some more of the impure silver into the anode basket here. Crystals have been growing for about an hour and a half since the last time I pushed them down, and they're almost up to the anode basket here. I'm going to go ahead and press them down again. This is the end of day 2. I'm going to go ahead and turn this off. When I'm not here, I've got to turn this thing off. The crystal grows too rapidly. And if I'm not here, it'll make contact with the anode basket there. So I'm going to press this down. I've already shut the power supply off. And then when I come back out tomorrow, I'll start it back up. This is the end of day 3. I'm going to go in now and get some rest. I'm going to turn the cell off. As you can see here, the crystal growth has grown up to within about a ½ inch of the anode basket. I've been shoving those crystals down all day like this. I'm going to go ahead and turn our power supply off. Shove these crystals down. I'll go in and get me some rest. I'll come back out in the morning and start it back up. You got to do this every hour. This is the 3rd day of operation. This is day 4. The crystal growth is increasing. The level of silver in the cell there is starting to build up. Another 5 minutes and those crystals would begin to touch that anode bag and create a problem. So I'm going to go ahead and knock these down. This is day 4. Got to constantly knock these down, otherwise the crystals will contact the anode basket, burn through the anode filter, and contaminate our batch of pure silver crystal. I'm going to go ahead and wrap this up for today by turning our power supply off and securing the cell for the day. I just turned it off here and now it's secured. Come back out tomorrow, start it back up and keep going. This is day 5. The silver cell is starting to get kind of, the levels increasing here, so it doesn't take long for these crystals to grow up near the anode basket. It's only been a ½ an hour since the last time I pushed them down. So what I'm going to do is I'm going to go ahead and push these down again. You got to make sure and wear gloves. You don't have to have nitrile gloves, but get something on your hands to protect them from this electrolyte. It's made out of silver nitrate and it will sting your hands black. This is day 5 of the silver cell operation. You can see in the anode filter here that most of the silver, it's down at least halfway there. So a lot of it's been consumed by the process, the refining process. I've had this on now for about 30 minutes and the crystal level in here has gotten to the point where it's growing up and I'm having to come out here every 20-25 minutes to tamp it down. So what I'm going to do is I'm going to shut this down and harvest this crystal out of here. Notice that the color of the electrolyte is turning blue. That is from the copper that's in the impure silver shot that we're putting through the anode filter up here. The copper dissolves and goes into solution into the electrolyte. It's not a problem, and then the silver cell will tolerate up to 60 grams per liter. before the copper starts plating out with the silver. All right, we're going to go ahead and turn the power supply off here. Remove the clip from the anode bar up here in the anode basket. Remove the clip from the cathode down here. Get those out of the way. I've got a beaker here, and I'm going to take the anode bar and just place it in this beaker and save it. I can use that again. Okay, I've got the beaker that has our residual electrolyte here, and what I'm going to do is I'm just going to take and transfer our anode basket right over here. Let it drain out a little bit there, and just transfer it right into this beaker. Doesn't matter if it drips down and gets in here. I'll be adding some more of this electrolyte to this cell when we start it back up anyway. Okay, now I'm going to go ahead and pour off the electrolyte out of the cell here into a clean beaker. Let's see if I got the angle right here. I'm just going to carefully pour off the electrolyte in this clean beaker here. Set the electrolyte off to the side over here. I'm going to reuse this. Now I'm going to go ahead and get the crystals out of here and rinse them off real good. Now what I'll do is, let me move this camera over here. What I'll do is transfer the crystals from this beaker into this 2-liter beaker here. It's easy to do, just kind of pull out the whole wad along with your cathode. Just kind of shake them off like that. Those that are remaining in here can just be, actually we can just pour this electrolyte over here into the, we want to save as much of that as we can. I got distilled water I just added there. I'm just going to get the rest of these crystals out with a little distilled water. Don't have to get it completely clean because we're going to just be reusing this to start the cell back up. Put the cathode back in here. Set the crystals off to the side here. And we'll reassemble this cell. Alright, now I'm just going to go ahead and pour this electrolyte right back in the cell. Reuse it again. It's a little bit bluish green color. That's telling me there's a little bit of dissolved copper, but I can tell by the pale blue color that we haven't exceeded the limit for copper saturation for the cell, so we should be good to go to use this at least one more time to keep refining our silver. Alright, I'm going to take our anode basket over here, and I'm going to place that on top of this beaker. I'm going to add a little bit more of the electrolyte because as the cell operates, some of the silver will come out of this solution and it'll weaken it. So I'm just going to go ahead and pour some of this right on in to replenish the electrolyte in the cell. That's up to the 1000 ml level. That's just about perfect. Now I'm going to go ahead, put the anode basket right back on there. Get submerged. Hook up the negative side to the cathode, or graphite cathode. The positive side is going to go back up here on our anode bar. Get it out of our beaker here. Clip the bar on, or the positive side of the power supply back onto the anode bar. Start it back up and keep going with the cell. I'm going to add a little bit more impure silver shot to the anode basket here. Pull that anode up from the bottom so it doesn't dissolve. We want to try to be able to use this anode bar over and over again. As long as we keep it out of the electrolyte and down at the bottom of that basket, that bar, that anode bar, can be used over and over again. I've got our pure silver crystal in the beaker there. Over here I've got some distilled water boiling on the stove there. Well, it's actually not boiling, but it's probably up to 180 degrees. It's best to use hot water to do these rinses, I've found. And so what I'm going to do is just go ahead and add some of the hot water to our beaker here. First let me pour all the electrolyte that I can here. Okay, the idea here is to rinse all the electrolyte off of the silver crystal. Just add some hot water to it, and then I take a thick glass rod and I stir it up real good in there, making sure that as much of the electrolyte gets rinsed off as possible. And then I just add that to this jar down here because it's still got some silver in it, and I want to recover that silver out of this rinse water. Now I'm going to do a second rinse. Hot tap water here, about 180 degrees. No, hot distilled water, not tap water. This is distilled water. About 180 degrees. You can't use tap water here because it'll form silver chloride in here, something you want to try to avoid. So we're using hot distilled water to rinse these crystals off. Okay, this will be the third rinse with hot distilled water. This time what I'm going to do is take a little sample in this small beaker here, and then I'm going to add some hydrochloric acid to it and see if we precipitate any silver chloride. If we do, that means we need to continue rinsing. If we don't, that means what we're going to do is rinse one more time just for good measure, and then we'll go ahead and dry out the crystals. Alright, now what I'll do is add some hydrochloric acid to this. If I get a cloud of silver chloride, that means we still got to rinse. And you see I do. Still got silver chloride in the rinse water. That means we got to rinse those crystals some more. Fourth rinse here. Hot distilled water. Okay, this will be our fifth rinse. Hot distilled water. Get another sample of this rinse water and see where we are with the rinsing. Not too much silver chloride forming there, but I'm going to go ahead and give it another rinse. Looks fairly clear. We'll pour this off and give it another rinse. Okay, this will be the sixth rinse. Hot distilled water here. This is our sixth rinse. I'm going to go ahead and test this one again, see if we got all the silver chloride out. Here's our clear liquid. Add some hydrochloric acid. And if we got silver in here, it'll turn cloudy. And it stays crystal clear with no traces of silver chloride. So it's safe to conclude that that silver crystal's been rinsed free of the electrolyte. Alright, I've got a lid on this silver chloride jar here. I saved this for later recovery. I've got all the electrolyte off of the silver crystal. Looks like diamonds in there. What I'm going to do is put the heat on low down here and put it into a casserole dish and evaporate off all the water. The silver is completely dry now. All the moisture's out of it. I've got a dish here that I've got the weight written on the side. It's 693.3 grams is the weight of the dish. I've got my scale here zeroed out. We're going to weigh the dish and the silver now. And what we get is 1,000.9 grams. So to calculate how much silver I got in there, what I'll do is take 1,000.9 grams minus the weight of the dish, which is 693.3. 693.3, and that equals, so we got 307.6 grams of pure silver crystal in this dish. Alright, now what I'm going to do is convert this over to troy ounces. Got a melt dish here. I'm going to zero out the weight of the melt dish. And then I'm going to load this melt dish up with some silver. And we're going to melt this up into a bar and then post it for sale online. I've got about 5.08 troy ounces of pure silver here. What we're going to do now is go out to the melt table out here, melt this up into a bar, and see if we can sell this thing online. Okay, here's our fine silver bar, probably 3/9 fine or better. It's got a little piece of flux on it right there. Got a little frost to it in the center, but that's okay. Let's put it on the scale here and see how much we weigh. We got 5.1 troy ounces. That's because I added just a touch of silver before I started that melt to make sure I was over 5 ounces on this bar. So I got 5.1 troy ounces. Here's the restart using the same electrolyte. This is the second go around with this electrolyte. You can see how much silver's already grown in there. It's been running now for a couple hours, I guess. Okay, this will conclude the third part of the three-part series of my silver refining videos. I was able to take this cement silver that we got in parts 1 and 2, melt it in the impure shot, and then run it through the silver cell. And I got some pure silver crystal here. It's pretty dazzling looking. It's nice and bright and shiny. Got some real nice reflective surfaces. Looks real good. This is the remnants from that was left over before I melted this bar. And then I've got this bar that I melted up. It's got 999 fine silver on it. It's got the date 2018-0903, which is the 3rd of September. And then 5 troy ounces. It actually weighs 5.1 troy ounces. I added a little extra silver. I always do that to my bars to make sure they're not underweight. And then I stamp my name down here, Sri Tips. I'll be putting this up on my eBay site. Just type Sri Tips in the search block on eBay and you'll be able to find this. And we'll put it up for bids and see what it goes for and have a little fun with that. Anyway, this concludes the 3-part series of the silver refining video. I hope you learned something. And I check my comments section every day. If you have any questions, feel free to ask them. And if I can answer them, if I've got some experience with it, I'll answer those questions for you. If I don't, I'll just tell you I don't have any experience with it. So anyway, thanks for watching.